Good morning, students. In earlier classes, we have discussed about the Fourier transformation of a function, Fourier sine transformation of a function, and the Fourier cosine transformation of a function. Also, we have studied about the inverse Fourier transformation, the inverse Fourier sine transformation, and the inverse Fourier cosine transformations. Also, we have studied various problems to calculate these transformations. So, in order to calculate these transformation, today we will discuss some more problems to calculate these transformations. Here, we have to calculate the Fourier sine transformation. Fourier sine transform. As we know that the Fourier sine transformation of a function fx is fsp, and this fsp is equals to Fourier sine transformation of a function fx with respect to parameter p. And this is equals to root 2 upon pi integral 0 to infinite fx sine px dx. We know that the Fourier sine transformation of a function fx is equals to given by root 2 upon pi integral 0 to infinite fx sine px dx. Now we have to calculate the sine transformation. Find Fourier sine transform of fx where fx is equals to, the function is given, the function fx is given as x if x lies between 0 and 1. The value of the function is 2 minus x if x lies between 1 and 2, and the value of the function is 0 if x is greater than 2. We have to calculate the Fourier sine transformation of a function which is defined as this one. Now, the solution of the problem. We start with the Fourier sine transformation, which is fsp. This is equals to Fourier sine transformation of the function fx, and by definition this is equals to root 2 upon pi integral 0 to infinite fx sine px dx. As the function fx is defined in different intervals, so first we break this integral in those intervals in which the function is defined. So this is equals to under root of 2 upon pi integral, first interval is 0 to 1, so 0 to 1 fx sine px dx root 2 upon pi. The second one is 1 to 2 fx sine px dx, and the third one is under root 2 upon pi integral 2 to infinite fx sine px dx. As the function is defined in the interval 0 to 1, in 1 to 2 and 2 to infinite, if we put the values of the function in those intervals, then we get this is equals to under root of 2 upon pi integral 0 to 1 fx in this interval is x, so x sine px dx plus under root 2 upon pi integral 1 to 2. In this interval, the value of the function is 2 minus x sine px dx, and in the third interval, this is root 2 upon pi integral 2 to infinite, the value of the function is 0. So 0 sine px dx. So it remains, this is equals to under root of 2 upon pi integral 0 to 1 x sine px dx plus under root 2 upon pi integral 1 to 2 minus x sine px dx. Now if we integrate these one, then we get this is equals to under root of 2 upon pi. The integration of x sine px by parts, we get it as the integration of this one is x cos px upon p with minus sign. The limits are from 0 to 1. The integral of this one is x sine px, that is minus of x cos px upon p. Limits are from 0 to 1 minus integration 0 to 1 x, differentiation of x is 1, so cos px upon p with minus sign, so this is plus dx. Similarly, on integrating this one, we get under root 2 upon pi. If we integrate 2 sine px with respect to x, then we get 2 sine px is 2 cos px upon p with minus sign. The limits are from 1 to 2. And the integration of x sine px is the same, so we get it as root 2 upon pi, this is 1. So the integration of x sine px is minus root 2 upon pi. The integration of this one is minus x cos px upon p. The limits are from 1 to 1 to 2 minus plus integral 0 to 1 cos px upon p dx. Now again integrating the remaining part, we get this one as under root 2 upon pi. Values of this one, if you put the values of this one is then minus x, that is 1, so cos p upon p, minus 0 cos p upon the value of x is 1 minus cos p upon p. Integration of this one is plus integration of cos p is sin px upon p, so this is sin px upon p square, and the limits are from 0 to 1 minus 2 under root 2 upon pi. If we put the limit of this one, then we get minus 2, that is outside the integral. This is cos 2p upon p minus cos p upon p. And the integration of this one, if we put the values of this one, then minus root 2 upon pi. If you put the values of this one, then the values are minus 2 cos 2p upon p plus cos p upon p. And the integration of this one 0 to 1 cos px upon p is sin px upon p square, and the limits are from 1 to 2. So finally, if we put these values, then we get under root of 2 upon pi minus cos p upon p minus sin p upon p square, minus cos p upon p this is plus sin p upon p square minus 0 minus 2 cos 2p upon p plus 2 cos p upon p plus 2 cos 2p upon p plus minus cos p upon p minus plus sin 2p upon p square sin 2p upon p square with minus sign rather this is minus, so this is minus sin 2p upon p square plus sin p upon p square. So by integrating this one we get the result this one, and finally if we solve this one we get under root of 2 upon pi. We get the values of this one is 2 upon pi, this cos p upon cancelled, this one is also cancelled and many more are cancelled, only we get minus cos p sin p upon p square minus sin 2p upon p square. We get this one minus cos p upon p minus cos p upon p, 2 cos p upon p, this is cancelled. This is minus cos p upon p, this one also cancelled. Sin p upon p square and minus sin 2p upon p square. So we get it as 2 sin p upon p square minus sin 2p upon p square. Or finally we get under root of 2 upon pi. If we put sin 2p as 2 sin p cos p and 2 is taken outside this one, so we get sin p is also taken outside, so we get sin p this is 1 minus this is cos p upon p square. So 2 under root 2 upon pi sin p into 1 minus cos p upon p square, which is the required result. So we can get the Fourier sign transformation of the function in this way. Thank you very much.